The one-cycle engine is a brand new concept of internal combustion. The following slides will highlight some of the unique characteristics and compelling advantages that it offers. Most important, though, is that when the one-cycle engine is integrated into a vehicle system, it will have unparalleled flexibility to deliver both performance and efficiency, which was not possible before. Based on a newly patented positive displacement rotary device, this innovative engine has a deceptively small footprint and conceals a set of 6 rotary pistons operating in dynamic balance. In parallel, they complete all 4 cycles of the well-known but modified Otto cycle. In one revolution, this very simple design executes the combustion, compression, intake, and exhaust events 36 times. The conceptual design exists and is illustrated with 3-dimension CAD models. It is positively supported by peer review for its technical feasibility. One is ready for the world now. 2 identical outer cases with 6 chambers in case of rotating disc. Hydrodynamic lubrication allows the disc to freely rotate while creating a seal between the disc face and the chamber walls. The 6 3-eared drive plates function like one-way pistons, sweeping through each chamber as they rotate within the disc slots. Viewing a pair of chambers, it can be seen that the 4 cycles of internal combustion are completed simultaneously. Each sweep of the drive plate does 2 things. Compression occurs ahead of the drive plate, which is currently drawing fresh air into the chamber behind it. Also, combustion, which is pushing the power stroke drive plate, has exhaust ahead of it, which is being displaced towards the exhaust port. The combustion in this design is semi-external. Each of the 6 combustion pucks are located to receive a compression cycle. The fuel and ignition is introduced at this point, and the expanding gases are directed to the power stroke. The modular design of replaceable combustion pucks allows for rapid prototyping of alternate versions. The versatile designs range from a completely valveless external combustion engine to a highly sophisticated system which uses regenerative braking energy. And when needed, each chamber can fire up independently until all 12 chambers put power to the road. It is simply a better use of fuel to burn it only when needed. The one-cycle engine system leaps ahead with fuel efficiency. Power on demand stops the waste of fuel when there is no command for power. The engine is designed for intermittent operation, similar to a hybrid, but without the conversion losses associated with charging and discharging. Regenerative braking is mechanically incorporated into the compression cycle event. The energy is pneumatically stored for later use to assist the engine. Internal losses are reduced in 3 ways. When a conventional engine is throttled, the pistons must be pulled down against a low pressure or vacuum. This takes work and consequently fuel. The dilemma is that a high-speed idle must be maintained so that there is enough inertia to complete the cycles between power strokes. This problem is eliminated in the one-cycle engine. All 4 Otto cycles are completed simultaneously, and the need to carry inertia is gone. This allows the engine to operate from 0 RPM with full power. A system with control for regenerative braking additionally modulates compression to deliver just the right amount of air and fuel instead of causing an internal conflict associated with the problems of throttling. Finally, the number of parts and the overall complexity of conventional engines are dramatically reduced. The moving parts operate at a significantly lower speed, subjecting them to considerably less friction and wear. The one-cycle engine brings new possibilities of design for engine systems. This is important because it is not just a better engine, it is a better engine system. An intelligent and adaptive engine system can vary the speed and power independently. New engine parameters are controllable. Compression ratio, compression volume, and power stroke length. Unheard of before. And it's interesting to note that today you can get a pair of shoes with more sensors and CPU processing power than is needed for this. If the world switches to hydrogen, the water byproduct of burning hydrogen would conceivably be a good method of lubrication and cooling. This is a very interesting opportunity to explore later. And the possibility of using ceramic materials should be considered early in the development process because the robust design has almost no local stress points, which cause microcrack. 6 key advantages. Full power can be switched on from 0 RPM. A fuel savings when other engines idling. Highly flexible engine parameters. An adaptive multitasking engine system. Reduced internal losses, and cheaper to build, operate, and buy. The one-cycle engine has a solution, which is needed now.